Question 1. Potter believes that 20% of pots break whilst being fired in a kiln. Pots are fired in batches of 25. So let's have a look at part A. Let X denote the number of broken pots. So that's our test statistic. A batch is selected at random. We're told the significance level. And look, they're even telling us to find the critical region for a two-tailed test for the Potter's belief. You should state the probability in each tail of your critical region. Okay, so let's have a look at part A. Let me see, I've got part of it ready. Okay, so you're told then that we had a batch of 25. We know it's a binomial because we have got a success or failure at each trial. The pot breaks or it doesn't break, and the Potter believes 20% of them break. Now, because it's two-tailed, this means we're going to look at the alternative hypothesis that P is not equal to 0.2. Although I don't think you need the hypothesis as such in that first bit of the question. Okay, so just reminding you, I expect to get around 5 broken pots in a batch of 25, because remember how to get the expected value, we do 25 times 0.2, n times p. So I expect to get around 5. So then on my calculator, I'm going to find my critical region, so I can go into binomial CD. I can then let me just move that out of the way. I can then literally just simply do binomial CD, n as 25, p as 0.2, and I'm going to try x less than or equal to 2. Now, it was a 10% significance level, and it is two-tailed though. This is how bad it is writing with these things. Okay, so it's two-tailed, so I've got to get close to 5%. So less than or equal to 2 gave me 0.98 when I did that on my calculator. Okay, so that's still too big. Less than or equal to 1. Remember, I've got to half that significance level. I've got to get below 5%, or as close as possible to 5%. That gives me 0.0274. Okay, so I've dipped below 5%. So that's one critical region. What do we have to find the critical region? So x less than or equal to 1 is one of my critical regions. Now, you don't have to go up very high to find the upper tail, because remember, you're only expecting to get around 5 broken pots, so you're not going to be right up here around sort of 20, 21, 22. So I can actually start quite low. X greater than or equal to 8. So on my calculator, I've done probability x less than or equal to 7 was 0.891, and I'm going to take that away from 1, which gives me 0.109. Okay, so that's above 10%, so that's too high. So then on my calculator, I can do x less than or equal to 8, which gave me 0.953. If I do 1 minus that, I get 0.047, which gets me below 5%. Because it was two-tailed, it's got to be below 5%. Let's just check, have I done that? You should state the probability in each tail. So clearly, this is my other critical region here. X greater than or equal to 9 is my other critical region. You could argue that your actual critical region is x lies between 0 and 1 inclusive, because it can't go below 0. And x lies between 9 and 25 inclusive, because it can't go above 25. But those two answers are fine for now. X less than or equal to 1, x greater than or equal to 9. Okay, let me just have a look at part B. This is complicated, sharing the screen. Okay, so part B, the potter aims to reduce the proportion of pots which break in the kiln, and he's going to increase the size of the batch now to a size of 50. He then chooses a batch at random, and he actually discovers this was his observed value of 6 which broke. Test at the 5% level of significance whether or not there's evidence that increasing the number of pots has reduced. So we definitely want P to go down. So that sounds like a one-tailed test now. State your hypothesis clearly. Okay, let me see if I can try and go back to where we were. Okay, so I've started it off for you over here. So I've now increased my batch size to 50, and this was the null hypothesis. P remains as 0.2. Remember, X represents the number of broken pots in a batch, and we want to see if the number of broken pots has been reduced. So P less than 0.2 is my alternative hypothesis. Okay, so it's definitely one-tailed this time. So I expect to get, let's see if I can get this writing again. I expect to get N times P number of broken pots. Oh dear, I'm all over the place with this now. So 50 times 0.2, I'm expecting to get around 10. Okay, so now my p-value, I think I was actually given, rather than doing critical regions this time, you can do critical regions again. I might as well just use my p-value. So the p-value, remember, is the probability of your observed value or more extreme. More extreme is moving away from the expected number. So if the observed value is 6, moving away from that expected number, I'm going to be looking at X less than or equal to 6. I'm just going to find that. So I can do that easily enough in binomial CD. Remember now, P is 0.2, N is 50, and I'm letting X equal 6 in binomial CD. Okay, so that gave me 0.103. You could have used critical regions. I think if you use critical regions, the critical region turns out to be X less than or equal to 5, which is around 4.8%. Okay, I've used the p-value, so I can see 10.3%. Oh, I'm rubbish with this pen. 10.3% is painfully slow, isn't it? 10.3% is greater than the significance level. The significance level was 5%. Okay, so therefore it is not significant enough. It is not that unusual. So we don't suspect anything has changed. So we will be accepting, there's a bit of a delay, accepting H0. I can normally write neater than this, by the way. I can accept H0. Okay, so there is not enough evidence. I won't bother trying to write it because it will take me too long. There's not enough evidence to suggest that there is any change in the percentage of broken pots. It has not been reduced. And I think that's all you've got to do for question 1.